guys, welcome to lesson 6.4. Today we're going to be learning about comparing linear and nonlinear functions. So the first thing that we want to make sure we can do is identify a linear function. So if we had a table of values like this, where we have our x, y, remember we could write them as an ordered pair like this and graph them. But if we're just looking at the table of values, and if we notice we are adding on the same number to go from one number to the next, which here is adding on 3. And on the bottom, we are adding or subtracting the same amount. So here we're subtracting 8, and subtracting 8. If you find the pattern is either adding or subtracting as you go along the table of values and it's the same quantity, we could write a slope from that, right? We know it's the change in y, -8, over the change in x, 3, and that would be our slope. When we have a constant rate of change or a constant slope, we know that this is going to be a linear function. And we get that by analyzing the table of values. Let's look at another table. As we analyze this table of values, we notice that our x values are increasing by 2 as we go along the table. However, when we look at our y values, we notice that they're increasing by 9, and then increasing by 22, and then increasing by 55. That is not a constant rate of change. And so we would say that it does not increase by a constant rate, so the function is non-linear. Okay? All right, now I want you to consider some different functions. If you have a function that has any kind of curve in it, we would say this is non-linear, right? If you have a function that is a horizontal line like this, remember, to be a function, it has to pass the straight line test. So we would say, yes, this is linear. And if we had one that could be written in slope-intercept form, have a constant rate of change, we would also say this one is linear. Okay? So this one's nonlinear. Basically, linear is a straight line. However, the one situation I want you to think about is if you had a vertical line, would this be a linear function? And if you say, it still has to pass the straight line test, does this pass the straight line test? No, it does not touch the line in only one spot. It touches it in all spots. So a vertical line would not be a function. Okay? So as we return to our learning target about comparing linear and nonlinear functions, we've seen how to do that from a table of values and also from a graph. So let's look at a table of values that is written in a little bit different form. If we have x and y straight up and down like this, we would have to examine it in a little different way. So as our x values increase, we're adding 7. Hey, this looks like we're adding at a constant rate. Here we are subtracting 5, and you notice that we have a constant rate of change. As x goes up by 7, x goes down by 5. We could write this as a slope of -5 over 7. Remember, it's the change in y over the change in x. So we know this would be linear. Okay? Another example I want you to consider is this one. This would be considered a function because it passes the straight line test, but in order for it to be linear, it has to continue on in a straight line. So this part is a line, this part is a line, but it does not meet our definition for linear because it makes this sharp curve right here. So we would call this non-linear. Now I want to remind you of our basic form of a line, y equals mx. And this is what we learned for something that shows direct variation. It's going to be a line that goes through the origin and it increases at a constant rate. So this m out front is going to be our slope, right? So if it goes up 4 over 3, we would say our slope is 4 over 3. So as x increases by 1, y increases by 4/3. That's how it works. All right, so When you are looking at an equation and trying to decide whether it represents a linear function, linear is going to be in this form, y equals mx. So it could be something like this, y equals pi times x, right? Because pi is just a constant, it's 3.14. So it's like about like saying y equals 3x. That would be linear. Now, if we have an equation that it requires you to use the distributive property, you would want to do that first before you evaluate whether it is linear or nonlinear. So we'd have y equals 4x minus 4. This looks just like our slope-intercept form, so we would say this is linear. Okay? Now, one thing that I do want you to know is that if you have y equals, let's say, 4 over x, you cannot rewrite this in slope-intercept form. So if you have x as your denominator, this is going to be non-linear. Okay? Also, if you have, oh, I think that's about it. Now, I want you to be able to analyze a real life situation and analyze a graph and tell from the graph which one is linear and which one's nonlinear. So we look at the blue line, and it continues at a constant rate. We would say that's linear. The red line does start to depart from the blue line and increase at a faster rate. So we would say the red line is nonlinear. And you can look at that from just looking at this. This goes up by 10 each time. This goes up by more than 10 each time. I do want to give you one more hint there. See, if you look at this one, you have x in the denominator, so you could think of it as 4/3 times x. So you have a constant slope times x. That would be linear. However, if you have x squared at all in your equation, it is going to be nonlinear. So as we return to our learning target, you can compare linear and nonlinear functions. You're going to use data tables, you're going to use graphs, and you're going to use what you know about slope-intercept form to look at equations and tell whether they are linear or nonlinear too. So remember, a key, if you have x in the denominator, nonlinear. If you have x squared, non-linear, okay? Keep an eye out for those things as you do this assignment. You will also have some real life problems that you will have to solve using what you know about linear and nonlinear equations. So again, look for that constant rate of change. If there is a constant rate of change, then it will be a linear function. If there is not a constant rate of change, then it will be nonlinear. So good luck with that, and thanks for watching.